Hello everyone, my name is Thant. My teammates are Juan, Julio, and Jim, and our project is the pizza tosser. The traditional method of pizza tossing can be time-consuming and tiresome. Resources are also wasted on training employees to toss pizza. This is why our team has designed the first ever pizza dough tosser. This machine will increase efficiency in the kitchen and always be consistent on making an airy circular dough. The pizza dough tosser is the first one of its kind and it consists of simple mechanical parts to do complex tasks. Our parts consist of linear actuators and two gears from McMaster car.
Our device tosses the pizza by using four actuators pushing the platform up as shown in the GIF on the right. In order to stretch the pizza dough, a motor is implemented in between the pizza plate and the platform to spin the pizza plate.
Our main goal was to spin the dough and pizza platform, a resulting weight of 15 pounds at a rate of 120 revolutions per minute. Based on the gear sizes chosen, the driving gear, the larger of the two gears, had to spin at a rate of 80 RPM. Due to these requirements, an electric motor that could provide 1.3 horsepower with a torque of approximately 1/6 foot-pound was chosen for our design. For our bending stress analysis, we use the AGMA standard equation. In order to use this equation for our stress analysis, a major assumption we had was that our contact ratios between the gears was between 1 and 2. To obtain our bending stresses, the torque provided by the motor was used to obtain the tangential force experienced by both of the gears. The resulting bending stresses show that the small applied tangential force does not warrant any concern over failure due to bending.
For the surface stress analysis on the gears, this is the driving equation to find stress. Many of the factors carry over from the bending stress equation. Only the surface geometry factor, I, and elastic coefficient, C sub P, need calculating. Surface geometry factor is found using the radii of curvature of the pinion and driving gear teeth, and the elastic coefficient is found using the Poisson ratio of the gear material as well as its modulus of elasticity. After this, we are able to calculate the corrected surface fatigue strength based on these factors, many of which also carry over from previous calculations. The corrected surface fatigue strength values were approximately 67,000 psi and 73,000 psi for the pinion and driving gear respectively. These values resulted in a safety factor of 74 and 89. Again, the safety factor is for surface fatigue failure, and this value, along with the safety factor in bending fatigue, tells us that we should not expect failure from either in our application, but that surface fatigue is slightly more of a concern because the stresses at the surface of the teeth tend to be higher.
There are improvements that could have been done to our pizza tosser. For example, selecting better gears could have yielded better results for the stress analysis. In addition, having a working actuator and a motor in SOLIDWORKS could have helped with visualization. Lastly, creating a working FEA would drastically improve the stress analysis. We have tried it, but we don't have enough memory to process the mesh. Thank you. Any questions?